Okay, in this video, we are going to be covering something called unit analysis or dimensional analysis. And basically, this involves converting from one unit to another. In measuring, we are always measuring in different units. And so sometimes we want to get from one unit to another, and this often happens, and we need a method of doing that. And so here I'm going to teach you a method that will help you get from one unit to the next in the calculations. We'll be going over certain calculations in this section, but we're going to be using this method over and over again throughout the course. So it's important that you learn how to use a conversion factor in these calculations. A conversion factor is a ratio derived from an equality. And so the key thing here is that this is an equality, things that are equal, two different units that are equal. And so an equality between two different units that can be used to convert from one unit to the other. And so here what they're using is the equality that 4 quarters equals $1. So here we're using American currency. And so any currency would work here, but here in American currency, 4 quarters is equal to $1. And this equality can be made into a fraction. So because these are equal, that's equal to 1. So 4 over 1, 4 over 1 doesn't equal 1, but when you include the units, that is equal to 1. And so here the units are just as important as the numbers for these conversion factors. Dimensional analysis, or sometimes it's called unit analysis, is something that takes us from one unit to the next. And so the way I'm going to set these things up is that we're going to have the quantity sought equal to the quantity given times a conversion factor. So for example, how many quarters are in $12? And so the way I'd set this up is I'd say how many quarters, I use a question mark, quarters, is equal to $12. Then I want to multiply by a conversion factor that will get us from one unit to the next. And the way that I do this is that whatever I'm starting out with, I try to cancel that out by putting that unit on the bottom of the conversion factor. And so if you have 2 over 2, that cancels out. Same with here, dollars over dollars. This unit would cancel out. And so this unit cancels. I've used this equality that for $1 there are 4 quarters. I multiply these numbers, and so I get the number from multiplying those numbers, and then the unit that's left over is quarters. So here, for example, a golfer putted a golf ball 6.8 feet across a green. How many inches does this represent? So the first step, use an equality that relates the two units. So what are our units here? We've got feet, and what we're looking for is inches. And so this is an equality. 1 foot equals 12 inches. And so two conversion factors from this are 1 foot over 12 inches or 12 inches over 1 foot. And so what we would do is take that number here that we're trying to convert, multiply by a conversion factor in which feet are on the bottom, so they cancel, and inches are on the top. Then we multiply 6.8 times 12. We get 82 for our number. And since these units canceled out, we're left with inches, and that is our unit. For metric system, earlier in the notes you saw the metric prefixes, and we can turn these into conversion factors. Here I'm using meters, but anything else can be replaced there, grams, liters, etc. And so it's set up that 1 megameter, or if this was grams, it could be 1 megagram, is equal to 1 million meters, or it could be grams, equals 10 to the 6 grams, whether you want it in scientific notation or regular zeros. Usually what I do is if it's a small number, I usually write it out like this. When it gets bigger, I tend to use scientific notation, but we will use these interchangeably throughout the course. And so here is a way that we can get equalities or conversion factors from this chart. And so for example, I could say that 1 centimeter is equal to 0.01 meters. And so here you see that centi right there makes that 0.01. So it's a way of holding that number in front of meters without actually writing the number. But you get an equality here. 1 centimeter equals whatever centi stands for, which is 0.01 meters. So let's practice that. We want to know how many centimeters are in 2.5 meters. So here is our question. How many centimeters? Here is what we are given. And so, first of all, this question says, what equality relates centimeters to meters? How can we relate centimeters to meters? So we just looked at this with our metric prefixes. 1 centimeter equals either 0.01 meters or 10 to the negative 2 meters. So 1 centimeter equals 0.01 meters. That is our equality. Then I'm going to set this up. I'm going to say how many centimeters. So this question mark I use to represent how many. If it says that, I just write a question mark. How many centimeters are in, that's like my equal sign, and then 2.5 meters. So this is centimeters, this is meters. So centimeters right here, this is what I'm looking for. This is what I want to end up with. Meters right here is what I'm given. And so what I want to do is multiply by a conversion factor in which meters are canceled out. That means I want to put meters on the bottom. This will always happen. You will always put on the bottom what you're starting out with. And so you'll always have this canceling effect. So you should always know what to put here. Sometimes what you put up here can be iffy, but what you put on the bottom is always going to be the unit you start with. Here I want to go to centimeters, and I can go straight to centimeters using this conversion factor or this equality. And so all I have to do is put centimeters there. That matches what I'm looking for right there. And then I just plug in what is true. And so here for 1 centimeter, for these definitions, the 1 always goes in front of the unit that has the prefix. The 1 goes in front of centimeter, and then whatever centi stands for is what goes in front of meter. So that's 0.01. Right there. And so what I'm going to end up doing then is multiplying and dividing. And so here, basically what I have is 2.5 times 1. You can just leave the 1 out if you want. Just ignore all the 1s. Divided by 0.01. So everything on the top is on the top multiplied. Whatever's on the bottom is divided. So that's where the numbers are. Then for the units, here meters will cancel. And we'll end up with centimeters, which is what we want. And so if you take 2.5, divide by 0.01, you get 250. The units that are left over are centimeters. So we've canceled out the units we want to get rid of. We're left with the units that we wanted to get. Here, how many grams? So that tells me I'm going to write how many grams are in, that's my equal sign, 3.6 kilograms. Right there. So I'm going to multiply by a conversion factor. And I know that what I'm going to want to do is get out of kilograms. So that's my first thing. If you do nothing else, you can do that. And so whatever I start out with, whatever unit I start out with, I want to put on the bottom. And then we want to see, can we go straight to grams with an equality? And we know that with our prefixes, which are back here, 1 kilo of something is equal to whatever that something is, 10 to the 3 or 1,000. And so here we know that 1 kilogram is equal to 1,000 or 10 to the 3 grams. So yes, we can go straight from kilograms to grams. This is what we're looking for. This is what's on the top, what's not canceled out. Then we put in our numbers. 1 kilogram, 1,000 grams. We see what cancels. The kilograms cancel, which is what we wanted. And we've got a 1 on the bottom, 3.6 and 1,000 on top. So 3.6 times 1,000. And then I can put that over 1, but you can ignore the 1 since it doesn't change anything. So we have 3.6 times 1,000. So that's going to move the decimal over 3 places. And so we get 3,600. And our unit is grams. So we've canceled out kilograms. We've ended up with grams. Here, we're asked for how many centimeters are in, that's our equal sign, 30 nanometers. So how many centimeters equals 30 nanometers? So what we're going to be thinking about here is, can we get from centimeters to nanometers? And the answer is yes, there is a conversion factor. However, that's not something that we are memorizing. So is there another way? And what we know is that each of these can connect to meters. We can take the prefix off of each of them and get to meters. And so that's what we're going to do. The first thing we do, put nanometers on the bottom. We know we want to get rid of nanometers. Those have to cancel. But we cannot go straight from nanometers to centimeters. We can, however, go to meters. And so that's fine. We go to meters. We just multiply by another conversion factor. We have meters up there. We want to get rid of that to get to centimeters, because centimeters is what we want to end up with. And so we're going to put meters on the bottom again. Meters and meters. So you have this cross canceling, and then centimeters on the top, because we know we can go from meters to nanometers and meters to centimeters. Equal that out. We have just taken care of all our units. Now all we have to do is put in numbers. So 1 nanometer is equal to 10 to the negative 9 meters. 1 centimeter is equal to 10 to the negative 2, or 0.01 meters. And so what we're going to do, these cancel, we end up with centimeters. We take 30, multiply 10 to the negative 9, divide by 0.01, and if you put that in your calculator, you should end up getting 3 times 10 to the negative 6 centimeters. If you're looking at significant figures, We're just looking at this, and there's only one significant figure here. And so we're fine with one significant figure there. So your answer is 3 times 10 to the negative 6. This last problem includes symmetric prefixes, but also includes a conversion factor which is given to you. I will usually give you these conversion factors. I do expect you to memorize the metric prefixes for the midterm right here, but anything else will be given to you. So here an iron sample has a mass of 4.50 pounds. What is the mass? So that's like asking how many. This is what is the mass of this sample in grams. So grams is what we want to know the mass of. And so we want to know how many grams, what is the mass of the sample in grams, is 4.50 pounds. So grams is what we're looking for. Pounds is what we're given. And so we know for sure that we want to get out of pounds. Pounds. And then they gave us this conversion factor that would take us to kilograms. So we go ahead, go to kilograms. Pounds. Kilograms isn't grams, but it's pretty close. We can get there. And so that is our in-between conversion factor. So here it says 2.2046 pounds and 1 kilogram. Now we can go from kilograms to grams. We know how to do that using our prefix system. We're going to cancel out pounds, kilograms. 1 kilogram is equal to 1,000 grams. And so then we take 4.50 times 1,000 over 2.2046. And the units will end up in grams. If I work that all out, put that in your calculator, you should get 2041.1866 and maybe some more numbers. Let's look back here. We need 3 significant figures. So we don't want to cut this off before that decimal place. And so what I'm going to do is 1, 2, 3. Put this